Hello dear students. So in our today daily dose topic, we will discuss about the Chick's law. So you know that guys, in our disinfection treatment unit, the number of microorganisms is trying to decrease because we have added the disinfectant in it, like our chlorination process. So we need to understand how much amount of microorganism is still remaining in the sewage or in our water, right? After adding chlorine or any other disinfectant, right? So let's understand in this particular session, guys. Uh, Let me tell you one more thing. You can subscribe our channel also, guys, for such type of video so that you can understand the small concept which can be very useful for your gate examination, right? So let's start this particular session. So let us consider this is our disinfection treatment unit, right? In which the initial number of microorganism is N0 and the number of microorganism which is present after time t is Nt, right? And let us consider the disinfectant which we have added into the disinfection treatment unit. It has a time of contact, which is nothing as it is the duration of contact between the microorganism and the disinfectant, right? So that is basically our time of contact. So let us consider our time of contact is T. And let us consider we have added C milligram per liter of disinfectant dose, right? So guys, we need to estimate how many number of microorganisms is present after time T. So let's calculate it by using our Chick's law formula derivation. So let us consider this is our time T, right, which is in minute, and this is our number of microorganisms which is present after time T. So guys, as you can see here, the slope of this particular curve is trying to decrease, right? The slope of this particular curve is trying to decrease. Now what is this slope, sir? Let me explain. So let us draw one point over here, guys. So this is our slope, which is basically theta. So can I say that this is nothing as this is the rate of change of microorganism with respect to time, right? Or the number of microorganism with respect to time, how much it is changing, that is basically our slope. So we can write here, guys, dNt by dt, and it is proportional to minus. Why we are writing minus? Because the slope is continuously decreasing. Let me show you that. Let us consider this is theta 1. If I draw another slope at another point, so you can see, guys, this slope will be what? The slope will be our theta 2 value, but theta 2 is less than theta 1, right? That's why our slope is decreasing continuously. So can I say that, guys, it is proportional to the number of microorganisms which is present at any time t. So now we need to remove this particular proportionality constant. So dNt by dt is equal to what? It should be minus k times nt, correct? Now what is k? That is nothing as our disinfection rate constant. Disinfection rate constant. And the unit of this particular parameter is time inverse. Clear? Now guys, let's derive it further. We can write here dNt by nt, and it is equal to minus k times dt. Now let's put the limit. When t is equal to 0, right? How many microorganisms we have? Let us consider the number of microorganisms which is present at t is equal to 0 is how much? Let us consider n0, which is nothing as our initial number of microorganisms. Kindly consider this particular end is connected to the y-axis. Okay, kindly consider it like this. Okay, so this is n0. And let us consider after time t, how many number of microorganisms we have? Let us consider this is our nt value. So can I say that, guys, this is the quantity or this is the number of microorganisms which is present? Clear? So initially value is nt and not, and the final value is nt when time t is equal to how much? It is t. So let's do the integration. We can write here ln nt, and our limit is n0 to nt, and it is equal to minus k times t. So limit is 0 then t. So we can write here, guys, ln nt minus ln n0 is equal to minus k times t, right? So our equation will be ln nt divided by n0 is equal to minus k times t. So we can write here nt by n0 is equal to e raised to power minus kt. So as per Chick's law, if you want to estimate the number of microorganisms which is present after time t is equal to what? Nt is equal to n0 into e raised to power minus k times t. And this is the relation which is recommended by the Chick's law. to find out the number of microsomes which is present after type T. So guys, kindly use this particular equation to solve your problems, right? Now I hope all of you are able to understand what is the relation which is given by the Chick's law. So kindly use it, and let's meet in the next one, guys, in which we will discuss the further concepts. Okay, so thank you so much for joining the session. Let's meet in the next video.